Okay? So arc measures are measured in degrees, arc length are measured into units like centimeters, inches, feet, whatever the measurement is. Okay, so just like arc measures are a portion of a circle's rotation, the arc length is going to be a portion of the circle's circumference. And the way that we find that portion is we simply take the corresponding arc measure, divide by 360, and that's going to give us the total fraction or portion of the whole circle's rotation that's accounted for within that specific arc length. And so the easiest way to kind of distinguish between these is to look at a case of two concentric circles. If I gave you two concentric circles and I cut off these two arcs, and let's say with a 90-degree angle, okay, are the arc measures for these two arcs going to be the same? Yeah, the measures are a portion of the rotation. They're both 90 out of the 360 degrees. So the arc measures for these will be identical. Now, will the arc lengths be identical? No, the inner circle is going to be a shorter length than the outer circle, right? That intuitively makes sense. And so the way that we find those measurements is we use this calculation for arc length. Okay, arc length is going to be designated with a lowercase s. And I'm going to use one of three equations. Okay, it all depends on whether the problem itself involves the circumference of a circle, the diameter of a circle, or its radius. In all of them, you're representing the measure magnitude of the circumference. It just depends on what they ask. You can use three different variations on it. Okay? So arc length is just m over 360, some fraction of the circle's circumference, and you can express that value of c, the circumference, in terms of the diameter d pi, so m over 360 times d pi, or circumference can also be expressed in terms of radius as 2 pi r, so you could also express it as m over 360 times 2 pi r. And I'll show you some examples of these, and kind of it'll indicate which equation to use. And so here's the first possible example. Now, if you want to find the length of this arc AC, and again, make sure you read a question carefully to find out, is it asking for an arc length or an arc measure? And so if you want the arc length of arc AC given the circumference of this circle is 10 pi. And so here they give you circumference. So that means you should use this form of the arc length equation. So again, if you see me write down the work on these, I would write the arc length S is equal to m over 360 times c. So that identifies which of the three forms of this equation I would choose. And then it's just a matter of plugging in the correct pieces. So I need my arc measure. So what is the arc measure for AC based on this information? 40, right? You have an inscribed angle. Oops, an inscribed angle is equal to 20, therefore its intercepted arc is double that, or 40. So you get 40 over 360 times, and our c value, the circumference, is just 10 pi. And so then it's just a matter of solving this. So we cancel the factors of 10. 4 goes into 36 9 times. And so we wind up with our overall solution, 10 pi in the numerator, 9 in the denominator. Again, it is a measurement, so we could, if you were writing this by hand, you would label your units. And you're not going to label units, you'll just enter your calculation online. Okay, but this would be one way to find arc length if you're given the circumference. Okay. Let's take a look at a different form. This time you're given a circle with intersecting chords. One of the chords happens to pass through the center of the circle, and that chord is said to be a length of 10. So that's your diameter. So now you should use this form of the equation. Express circumference in terms of diameter and solve the resulting equation. So if you say arc length is equal to some portion of a circle's circumference, so m over 360 times, and your measurement is in terms of diameter, so d pi, and then just plug in your pieces of information. So here's our m value. Okay, how would we find this measurement? Okay, 30 degrees is equivalent to the average of these. So you can do a couple different things. If you're very calculation oriented, you might say the angle has a vertex inside the circle, so it's 1/2 the average of m plus n, and then plug in the pieces. So 30 is 1/2 m plus the other arc measure, 50 degrees. Multiply by 2 to get rid of our fraction. we get 60 is equal to m plus 50. Subtract 50 from both sides, and you get m is equal to 10. So our value for m is 10 over 360 times d. The whole diameter was given as 10 as well. Pi. And now you calculate. So 10 and this factor of 10 cancel. You have like terms that go into, like factors that go into both 10 and 36, a 2. 2 goes into 10 5 times, 2 goes into 36 18 times. So you wind up with your answer 5 pi over 18. Again, whatever the units happens to be would be involved in your answer.